Hello world, what is going on? It's good to see you back here on the channel today, and we'll be seeing the second exercise of Codility lesson number 5, which is called CountDiv, and it's a very interesting exercise with a very clever solution where we'll have to find all the numbers between a range A and B that are divisible by K. And the range is or could be very large, so we can't take the naive approach of iterating over all the elements of the array to find the numbers that are divisible by K. So we'll have a look at a very interesting solution and we'll get a result in O1 constant time. Let's get at it. Okay, so as always, let's get started by reading the exercise description. Let's go ahead and go to CountDiv from Codility lesson 5. And let's read the exercise in Python, and it says, write a function that, given three integers a, b, and k, returns the number of integers within the range a, b, inclusive both, that are divisible by k, meaning that each number that's between a and b that mod k equals 0, that means it's divisible by k. So for example, for a6 and v11 and k2, your function should return 3 because there are three numbers divisible by 2 within the range 6 and 11 inclusive, that is 6, 8, and 10. So write an efficient algorithm for the following assumptions. A and b are integers within the range 0 to 2 billion, so that's 10 to the 9 times 2, and that's bigger than 10 to the 8, so even running a linear solution here wouldn't help. That's just too much of a range. And k is an integer within range 1 to 2 billion, so meaning the step could be as low as 1. So yeah, linear solution won't work here. And the other consideration is that b is bigger than or equal to a. Very important. So let's look at the explanation of the problem. Okay, so let's have a look at this exercise, or at least this example. We'll have an array between 0 and 10, and we'll have a k that's 3. So in this array, the numbers that are divisible by k, that's 3, are 0, 3, 6, and 9, right? So we're going to divide this exercise into three cases. Case 1, where a equals b. Case 2, where b minus a equals, it's less than k. And case 3, where b minus a is bigger than or equal to k. So in this case, where a equals b, this is really simple because this means we're only grabbing one element, and we need to check if that element is divisible by k. So we're going to return 1 if that element is divisible by k, and otherwise we're going to return 0. There's no surprise here. This is pretty straightforward. So let's go ahead into case 2. Case 2 is where b minus a is less than k, right? So in this case, case 3, so b minus a in this case could be 1, like in this example, because it's 2 minus 1, 1, or it could be 2, like on this example, right? So let's take a look at this example. I draw here on the bottom left a representation of the segment, and this is important. This is the closest divisible number by k that is bigger than a, right? So this expression would be important on all the cases, and we're going to divide a by k and take the CIL, meaning the upper integer of that division, and that will give us the closest number that is divisible by k to a, right? So in this case, a is 1, k is 3, divided 1 by 3 is 0.333, and when we seal that, we get 1, right? So x times k will be 1 times 3, which is 3, which is this number here, and this is the closest number bigger than a that's divisible by k, right? So what we need to do is to check if this number that we just calculated, x times k, falls within the range a and b. In this case, it doesn't, so we'll return 0 in this case, right? Let's take a look at another case. So in this case, we'll do the same thing. We'll calculate the closest bigger number that's divisible by k with relationship to a. In this case, a is 2, k remains 3, the division is 0.66, the CIL is 1, and the closest number relative to a that's bigger than a that's divisible by k is still 3, but in this case 3 does fall within the range a and b. And in this case, where we have b minus a with a limit of 2, this is 5 minus 3, the closest bigger than or equal number that's divisible by k relative to a, in this case is still 3, so we'll do exactly the same. We'll get our seal, which is still 1, we'll get the number, which is still 3, and we'll check in the range 3 to 5, and it does comply with this condition, so we'll have an answer of 1. So in this case, we'll check that b is 6 and a is 4. We'll do the exactly same thing. So in this case, 4 divided by 3 is 1.3. Seal that up, we have 2. X times k equals 6. So the number that's divisible by k, that's bigger than or equal to a, is 6, and 6 falls within the range a and b, so we have a 1 here. And we have one more case that falls within the same logic. We calculate the number that's bigger than a or equal than a, that's divisible by k, with the same formula, and we get the same result because this number falls within the range 4 and 7 actually here. So we'll have an explanation here for all of these cases that we're going to grab the number that's bigger than or equal to a, that's divisible by k, and that's closest to a. So if this number multiplied by k falls within the range a and b, we have one number that's divisible in that range, otherwise we have no number. So let's go ahead and look at case 3, where b minus a is bigger than or equal to k. In this case, we'll have a long range, and here we have one or more items that are divisible by k within this range. So I draw them like this. X in this case will be like the same that we have before, which is the number that's bigger than or equal than a, that's divisible by k, the first one. And we'll have x plus n, which will be the biggest number within the range a and b that is still divisible by k. And we're going to calculate this by dividing b by k and calculating the floor of that, right? Because if we put seal here, that will be the next biggest number than b that is divisible by k. So once we calculate x and x plus n, we'll just have to subtract these two. So first we're going to have to calculate x. In this case is 2 divided by 3, we'll seal that up and is 1. And x plus n will be 10 divided by 3, which is 3 because we're going to floor that. So that's actually 3.3. So here what we'll have to do is use this formula here. So we're going to subtract x from x plus n, and we're going to have to add 1, and this is important because in this case, as you can see, x plus n is 3, right? Because we have 1, 2, and 3 elements here, and x represents this one. So when we subtract this, let's say 3 minus 1, we are actually losing the first one because it's not including this item in the subtraction. So that's why we always need to have 1 to compensate for the subtraction of the first element that is divisible by k in this segment. So with this formula, we'll have 3 minus 1 plus 1 equals to 3, and that is the number of integers between a and b that are divisible by k. So the formula here will be to return the floor operation of b divided by k minus the seal operation of a divided by k and add 1 to that result. In this case, seal of a divided by k will give us this 3 right here, and the floor of b divided by k will give us this 9 here. So when we subtract these two and add 1, we'll have the desired result. And please note that these numbers here are the number that results of the division between this number in the segment and k. So in this case, this will be 3 and this will be 1. That's important. So without further ado, let's go ahead into the code. This is a very simple code and we'll check that out in Codility. Okay, so we're back in Codility. Let's go ahead and start this task. Let's select Python here. And we're going to delete this. Not that one. Okay, so we're going to implement what we saw in the problem explanation. So the first case is where a equals b. In this case, we're going to return 1 if a mod k equals 0. Otherwise, we're going to return 0. We're going to ask for the second case if b minus a is less than k, in which case we'll return 1 if CL of a divided by k multiplied by k is bigger than or equal than a, and it also has to be less than or equal to b, otherwise we're going to return 0. And we'll need to import from math CL and floor. And for the last case, we're going to ask if b minus a is bigger than or equal to k, in which case we're going to return the floor of b divided by k minus the CL of a divided by k plus 1, and that would be it. Let's check if this is working correctly. That seems to be working fine. Let's go ahead and submit this task. And we got a result back with a correctness score of 100 and a task score of 100. As we can see, our algorithm is running in O1 as expected because it's just a simple mathematical calculation, and it works even for the big test cases. Okay, that was it for this exercise. We saw how using a simple mathematical calculation and an understanding of the problem, we can get a solution in O1 instead of having to iterate over all the numbers in the range and getting a time limit exceeded. So if you like this solution, please hit the like button, subscribe to the channel, and share it with someone if you think it would be valuable for them. I'll see you on the next one. Bye!